Mrs. Smith is a fourth grade teacher. She uses a marble jar to keep track of her students' good behavior. Before the school year begins, Mrs. Smith puts 5 marbles in the jar. On the first day of school, she tells her students that for each day the class exhibits good behavior, 2 marbles will be added to the jar. How many marbles will the jar contain if the class behaves well for 4 days in a row? B. How many marbles will the jar contain if the class behaves well for 25 days in a row? All right, to answer these questions, we're going to take advantage of the fact that there is a linear relationship between the number of marbles in the jar and the number of good days of behavior that the class exhibits. Okay, so we're going to examine that linear relationship. All right, before we do that, let's define the variables that we're going to use. All right, I'm going to use x and y. Okay? And I'm going to use x for the number of days of good behavior and y for the number of marbles. All right, so let's do that. Let's say let x equal the number of days of good behavior. And let's say that let y equal the number of marbles in the jar. Okay. I'm also going to label them for the graph. So we're going to do a graph to show this linear relationship. All right, so here's my x-axis, here's my y-axis, and the x again represents the number of days of good behavior, and the y was the number of marbles in the marble jar. All right, now that we have our variables defined, actually, one other thing I want to mention. You might wonder, why did I choose x for the number of days, and why did I choose y for the marbles? Right, well, the answer to that is because we always want to use x for the independent variable, and we want to use y for the dependent variable. So the independent variable is the number of days of good behavior, and the dependent variable, that's the number of marbles. Right? And that's dependent because, well, just think about it. The number of marbles depends on how many days there are of good behavior. Right? The number of marbles depends on the number of days of good behavior. Okay? All right, so now let's go back to our question, and let's see what the story tells us about the relationship between x and y, the relationship between the number of days and the number of marbles. And we're going to record that data in a t-chart. All right, so we know that before the school begins, there are 5 marbles in the jar. Well, how would that look in our data? Well, remember, x is the number of days. So if x were 1, that would be the first day. If x were 2, that would be the second day. Well, we're talking about before the school year begins. So that has to be before day 1. Right? So that would be, we can call that day 0. Right? Before 1 would be 0. Right? So before the school year begins, on day 0, there are 5 marbles in the jar. So day 0, there's 5 marbles. Well, then after that, every time there's a good day, we're going to add 2 marbles in the jar. So on day 1, if they behave well, there would be 7 marbles in the jar. On day 2, if they behave well, there would be 9 marbles. And then on day 3, if they continue to behave well, there would be 11 marbles. Right? We need to assume that they're behaving well in order to answer these questions, right? Because we're seeing if they continue to behave well, how many marbles will they get for 4 days and for 25 days. All right, let's graph this. So on day 0, they have 5 marbles. On day 1, there are 7 marbles. So day 1, there would be 7 marbles. On day 2, there would be 9 marbles. On day 3, there would be 11 marbles. Right? And as you can see, there is a linear relationship here. All right, I'm going to go ahead and use my ruler to draw that linear relationship. All right, and we can use what we have here to answer question A. How many marbles will there be after 4 days of good behavior? Well, if we look at our graph, here's day 1, day 2, day 3, day 4. right here, on the fourth day, there would be 13 marbles, right? This is the point 4, comma 13. Right? So on the fourth day, there would be 13 marbles in the jar. And we could have also have done that by looking at our T-chart, right? Because on the fourth day here, if we follow this pattern, right, 11 would have to go up by 2 to become 13, right? So that's the answer for A, right? After 4 days, there are 13 marbles. All right, well, what about B? This one asks us for how many marbles will there be after 25 days. Well, and if we wanted to, we could do the same thing we did for part A. Right? We could go to 25 days on our graph. Right? We would have to make this bigger. Right? This graph's not big enough the way it is. But we could do that. We could go out to 25 days and see how many marbles there would be. And we could also do that in our T-chart. We could continue this pattern and go all the way down to 25 days. Right? And then see how many marbles there would be. Right? But maybe there's a better way. Maybe there's an easier way to do this. Right? And what I'm going to do is I'm going to use what information we have to create a linear equation that shows the linear relationship. We're going to use an equation that would be able to calculate the number of marbles in the jar based on the number of good days of behavior. In other words, we're going to calculate the y value, right? Because the y value is the number of marbles, right? And we're going to see how that relates to the number of good days. Right? Well, let's think about it. What do we know about the number of marbles? Well, we start out with 5 marbles in the jar. And then after that, we're adding more marbles. So the equation for y has to be y is equal to 5 plus something, right? Because we're starting out with 5 and then we're adding more marbles. Well, how many marbles are we adding? We're adding 2 marbles, but it's not just 5 plus 2, because it's 2 marbles for every single day there's good behavior. In other words, 2 times the number of days of good behavior, or 2 times x. Right? So this would be our equation. Y is equal to 5 plus 2x. And you can see this works for the data we have here. Right? If x were 3, right, 2 times 3 would be 6. 6 plus 5 would be 11. Right? So that would be our equation. Y is equal to 5 plus 2x. And we can use that to answer part B here. Right? How many marbles would there be after 25 days? Well, that's our x value. That's the number of days. So we can use our equation. Y is equal to 5 plus 2x. Right? My x value is 25. So let's replace x with 25. So 5 plus 2 times 25, we need to multiply first. So that's 5 plus 50, which is 55. Right? So after 25 days, there are 55 marbles. Okay? So if we were to show that in the graph, on the 25th day, we would be up to 55 marbles. Right? On the 25th day, there would be 55 marbles. Right? Before we continue, let's talk a little bit more about this equation. Make sure we understand the different pieces here. What are these pieces again? Right? Remember, this 5 here, that was what we started with. That's called the initial value. Right? That's what we start with. And you can see that here in the graph, or in the T-chart, right? On day 0, we're starting out with 5 marbles. And you can see that in the graph, right? We're starting out on day 0 with 5 marbles. This is the point 0, comma 5. And hopefully you remember that that is also called the y-intercept. Right? So that's what this 5 is. That's the initial value. Well, what about the 2? Right? What this is the rate of change. This is how much the marbles are changing every time the number of days changes. Right? It's 2. Right? And you can see that in the T-chart, because the number of marbles goes up by 2 every time the number of days goes up by 1. Right? Again, this goes up by 2 every time the x value goes up by 1. Right? So our rate, right, looking at this T-chart, is the fact that the marbles are going up by 2 every time the number of days goes up by 1. Right? 2 over 1 is the same thing as 2. You can also see that rate in our graph, because as I go from one point to another, you can see that I'm going up by 2 marbles every time I go 1 more day of good behavior. Right? Let me zoom in so you can see that. Right? So you can see I'm going up 2 marbles every time I go 1 more day of good behavior. Okay? And 2 over 1 is the same thing as 2. Right? You may recognize that in this picture as that's the slope. Right? So the rate of change is also called the slope. Okay? All right, so we have y is equal to our initial value of 5 plus our rate of change times x. The generic form of this equation is this. Y is equal to b plus mx. Right? So b is our initial value. This is our rate of change times x. You may recognize this equation as y is equal to mx plus b. That's the more common way of writing it. But I think this way makes more sense for this problem, right? Because we're starting out with an initial value and then adding this part. This is the number of marbles times, or the rate times the number of days, right? This is the marbles that get added every single day. All right, so keep that in mind for the future. All right, let's do our last 2 pieces here. C. If the class behaves well each day, how long would it take for there to be 15 marbles in the jar? Well, we can just look at our graph here and see that it goes through this point. Right? It's going to reach 15 marbles on day 5. This is the point 5, 15. Right? And it makes sense if you think about the t-chart, because the number of marbles goes up by 2 to 15 every time the number of days goes up by 1. Right? So it would reach 15 on day 5. Right? So it would take 5 days to reach 15 marbles. All right, last question. Mrs. Smith says she will give the class a special prize when they reach 99 marbles. If the class behaves well each day, how long would this take? Right? How long would it take to reach 99 marbles? Well, we could do that with the graph, right? But we'd have to make our graph bigger because we don't go up to 99 here. We could do it with the t-chart, but it would take quite a long time to get to 99 marbles. But don't forget we have our equation. Right? Our equation was this. Y is equal to 5 plus 2 times x. Our initial value of 5 plus the rate of 2 times x, the number of days. All right, and 99, that's the number of marbles we have, or we're trying to reach. So we're going to replace y with 99, because that's for the marbles. And we can solve for x. 99 is equal to 5 plus 2x. Well, to solve this, I'm going to subtract 5 from both sides. That gives me 94 is equal to 2x. And then I'm going to divide both sides by 2. That's going to give me 47 is equal to x. Right? So that means that it would take 47 days to reach 99 marbles. Right? So if we did that in the t-chart, we would see the same thing. If we went all the way to 99, this would take 47 days. And in the graph, we would, if we continued this further, it would, on the 47th day, we would be up to 99.